Hello everybody, this is Mr. Bohorquez here. I want to thank you for watching this video, Number Systems. This is lesson 4 in the series for the week of April 20th through April 24th. This video is learning objective. Will to be able to correctly calculate the product or quotient of positive and negative fractions. We see those numbers product and quotient are underlined. We're going to talk more about that later. And the question we want to be able to answer by the end of this video is, what do we do when multiplying or dividing positive and negative fractions? Now, before we go ahead and get started on this video, let's have a summary of our last video. In the last video, we were talking about fractions or rational numbers. We'll see that fractions consist of two pieces. The top piece here we call the numerator, and the bottom number here we call the denominator. And we can think of this numerator and denominator as parts to the whole, or how many pieces of there are there left from the whole amount. Now, when we want to add or subtract fractions, we must find a common denominator, or a number that's the same denominator. And we want to do that by using the lowest common multiple, the LCM. And the lowest common multiple was when we have one number that both of the denominators can multiply into. Before we really start getting ready to multiply and divide fractions, there's a couple of things we really want to know before we get into that. First, we want to recall that to multiply something is to find the product. And also to divide something, that means to find the quotient. So when you're multiplying two numbers or two fractions, you're finding the product. And when you're dividing a number or two fractions, you're finding the quotient. What's new on this video is now we're going to talk about a new term called the reciprocal. The reciprocal. Now, for a fraction, the reciprocal are when parts of the fraction switch. Okay, well, what does that mean? When we say the parts of the fraction, we're talking about the numerator and the denominator, or at least the number on top and the number on bottom. To find the reciprocal of this fraction, we're going to switch them. The denominator is then going to be on the top, and the numerator is then going to be on the bottom here. This is called finding the reciprocal of a fraction. For example, if we had the fraction here, 3 over 5, or 3/5, if we wanted to find the reciprocal, all we do is put the 3 in the denominator and the 5 in the numerator, or we just kind of flip them around. This is going to be very important in order to multiply and divide or find the product or quotient of fractions. First, let's talk about multiplying fractions. Now, multiplying fractions is not too difficult as it involves multiplying in the traditional way that we're used to. For example, notice if I have 2 over 7 or 2/7, and we wanted to multiply this by 6 over 8 or 6/8. Fortunately for us, when we're multiplying fractions, we do not need to find a common denominator if they don't already have one. In fact, with multiplying fractions, all we must do is simply imagine that we're multiplying the two numerators and that we're multiplying the two denominators. And that's what I mean in the traditional sense. All we're doing is multiplying across this little sign here. See, we have 2 times 6 in the numerator and 7 times 8 in the denominator. And then, using what we know about multiplying, 2 times 6 creates 12, and 7 times 8 creates 56. We could simplify this if we wanted to, but this is okay of an answer for us for now. One thing to notice is that when multiplying fractions, we're left with another fraction. These fractions, they don't change. Sometimes a fraction can be simplified into a whole number or an integer, but that's for another video. When multiplying positive and negative fractions, we want to remember that the same rules apply for when you're multiplying positive and negative integers. In the example here, where we have a negative 6 over 7, or 6/7, times a positive 2 over 5, or 2/5. The first thing we want to do is consider what sign is the product going to be, positive or negative. You may recall from the last videos that if we have a negative number times a positive number, this results in a negative number. Normally we would put this negative here in the numerator next to the 6, but because in the end the answer, the product will be negative, we don't have to do that this time. Now we just recall what we learned about multiplying fractions, and we have a 6 in the numerator times a 2 in the numerator. Then we have a 7 in the denominator times 5 in the second denominator. Again, we're just multiplying across this sign here. 6 times 2, well, in our case, negative 6 times 2, and 7 times 5. And that's going to give us, well, 6 times 2 is 12, and 7 times 5 is 35. Remember that this is negative, and you can put the negative right here in front. Make that a little more clear. There we go. And that's how we would, well, multiply a positive and negative fraction. Just remember, determine which sign your product's going to be in this case, and then just do the multiplying a fraction as you normally would. Now we want to talk about dividing fractions. Now this is going to seem a bit strange as it's a little different than normal. When dividing a fraction, we want to first find the reciprocal of the second fraction. That's why we had to learn that new term reciprocal today. And remember, that's when we have the numerator and the denominator switch. And then we want to multiply the two fractions. Well, let's try and do it with an example like this. We have 5 over 8, or 5/8, divided by 4 over 5, or 4/5. Well, it says here first we want to find the reciprocal of the second fraction. Well, let's see, 5 over 8 is my first fraction. Well, 4/5 here is my second fraction. The reciprocal of 4/5, if we put the 4 in the denominator and the 5 in the numerator, or we just switch these around, rather, that turns out to be 5/4. Okay, that makes sense. 4 over 5 then turns into 5 over 4. They're just turned around. And then it says we multiply these two fractions. Okay, well, let's try that. So that means that's equal to 5/8 times 5/4. Okay, I can see how these are a bit different. We found the reciprocal of the second fraction. So it says then just multiply. So that's just 5 times 5 in the numerator, and then we have 8 times 4 in the denominator. And I believe that gives us a 25 in the numerator and a 32 in the denominator. And again, if you want, you can try and simplify this if possible, but this is a good enough answer. Notice how, again, when doing this example, 5/5 divided by 4/5, we first had to find the reciprocal of the second fraction. So this 4/5 turned into a 5/4. Notice how the denominator went to the top and the numerator went to the bottom. Our next step was to then multiply these two fractions. Okay, so 5/8 times 5/4, and from what we remember about multiplying fractions, they just go right across. So 5 times 5 is 25. 8 times 4, let's make sure it looks like a multiplication symbol, is equal to 32. Now, this may seem like, hey, we're just multiplying fractions. What's the difference? Well, I kind of want to go back to where we were talking about opposites. In a way, multiplication and division, well, they're kind of like opposites within themselves. So one thing you can see here is when we find the reciprocal of this fraction, we're not just multiplying. We're actually kind of flipping this around. And when we're flipping this around, this gives us the ability to multiply. It's like we're finding the opposite here and then letting the math work itself out. So again, it may seem like we're just multiplying, but a key detail about dividing fractions is that first we must find the reciprocal of the second fraction, and then you may multiply. And then you get an answer that's correct, just like this one. Now, let's talk about dividing positive and negative fractions. Remember, with positive and negative, the same rules apply as they do for integers when multiplying and dividing. So first, in the example here, we have a negative 2 over 13, or 2/13, divided by a negative 3 over 10, or 3/10. One thing we can consider is that we have a negative divided by a negative. And if I'm remembering the other videos correctly, a negative divided by a negative is the same as a negative times a negative, which is a positive. So we don't have to worry about putting the sign here. Just keep in mind that it's a positive, in this case, quotient. Okay, well, in that case, now we must use our dividing fractions rule. So let's first find the reciprocal of the second fraction. Okay, so the reciprocal of the second fraction is, if it's 3 over 10, let's move those sides there. Let's see, that's the 10 in the numerator and a 3 in the denominator. Okay, well, remember, this is a negative times a negative makes a positive. So now we're just going to go on over here and suggest, let's see, we have, instead of writing these negatives, we know it's going to be negative. Let's just write 2 over 13, or 2/13, times, and now we have that reciprocal of 10/3. Okay, so we just want to multiply those two numbers. Let's see, that's 2 times 10 and a 13 times 3. And that should give us, let's see, 2 times 10 is 20. 30 times 3 is 39. Excuse me, 13 times 3 is 39. And that's going to be what our quotient is for this particular question. Negative 2/13 divided by negative 3/10. Remember, the same rules apply when you're dividing and multiplying positive and negative numbers. So we had a negative divided by a negative, and that gave us a positive. Then we wanted to find the reciprocal of the second fraction. Negative 3/10 turns into negative 10/3. And we multiply as such. Well, it's 2/13 times this new reciprocal here, 10/3. 2 times 10 is 20. 13 times 3 is 39, and gives us the correct quotient. Okay, everyone. Now let's go ahead and try and practice our new multiplying and dividing fraction skills with the following word problem. It takes 2/3 cups of sugar to make a cake, and you only have a 1/4 cup scooper. How many scoops of sugar will you need to make a cake? Now, in this word problem, it's going to require us to use a little bit of our analytical thinking skills and probably a little bit of our note-taking skills. I want you guys to go ahead and pause the video. I want you, during this time, to annotate. That means find out all the key information in this particular word problem that's going to help us figure out what exactly is it asking and what exactly is it telling us that we have, or at least what's already given information, okay? Go ahead and take the time to annotate and do what you can to solve this word problem here. And then we'll go ahead and get back to how exactly we're going to figure out the answer. Okay, I hope you guys took the time to go ahead and pause the video and annotate. That way we can figure out what exactly this problem is asking us to do and what is it telling us that, well, it's going to be helpful to answer that, okay? So first, what I do is I look at the numbers, or in this case, the fractions here, and I try and take them out. That way we know exactly what the numbers are that they're giving us. It says here that it takes 2/3 cups of sugar. So I'm going to circle 2/3 because that's a pretty important thing for us to know, to make a cake, and we only have a 1/4 cup scooper. Sounds like this scooper is not the same as that one. So we're going to figure out, well, what the question's asking. How many scoops, and I like to underline the question, how many scoops of sugar will you need to make a cake? Okay, so it's telling us we have the two fractions, 2/3 cups of sugar and a 1/4 cup scooper. So we're going to have to figure something out. The question is, what's this asking us to do? Are we going to subtract these two, add these two, multiply or divide them? Well, thankfully for us, we know that this is a multiplying and dividing fractions because that's what this lesson's about. So that eliminates those two options. But when considering multiplying and dividing, when we're asking how many scoops of sugar do we need, this scooper, it seems, if I'm not mistaken, smaller. In fact, if you were to think about it, let's say we have a scooper. Like, well, let's say this represents a scooper, just for funsies. And it's going to be divided into 3 pieces, such that there's 2 out of these 3 cups. This scooper, however, if we want to represent it as a fraction, or in this case a diagram, a little pie chart, well, it only takes about 1 of those. 1/4, because it's cut into 4 pieces. This is what we remember about fractions. Well, in this case, it seems as though this scooper, yeah, it is smaller than the amount it would take to satisfy that. So we want to know how many of these scoops are going to go into that one. Well, I guess technically we can just keep subtracting 1/4 to 2/3 until we get a number. Or when we think about it, rather than just continuously subtracting, if we recall how subtraction is kind of like division in the sense that, well, addition, repeated addition is like multiplication. So we can suggest that repeated subtraction is like division. There's a connection here. So it's safe to argue that, well, instead of multiplying these two fractions, we probably want to divide them. We want to exactly see how many of these go into here. And so that's what we're going to do. So when we have 2/3, well, we need 2/3 rather, and we only have 1/4, how many scoops of sugar? We're going to divide these two. And with that being said, our work comes out to be 2/3 divided by 1/4. That's what the word problem is asking us. And now we have to figure out what exactly is this quotient here. So let's go ahead and start doing our math, shall we? We have 2/3 divided by 1/4. Fortunately, these are both positive, so we don't have to worry about any sign changes here. Well, what do we recall about dividing fractions? We have to find the reciprocal of the second fraction. That means the 1 and the 4, they switch sides here, and this becomes 4/1. Now we're going to multiply these two fractions. 2/3, 2/3, oops, I almost put divided by, times, because remember we're multiplying the reciprocal, 4/1. And we're going to multiply this through, no problem. So we have 2 times 4/3 times 1. 2 times 4 gives us an 8. 3 times 1 gives us a 3. So according to our math, we're going to need 8/3 or 8/3 scoops from that 1 1/4 scooper. Now, you can write this as a mixed number, and that's another video if you wanted to, but for the sake of this lesson, this is a good answer. 8/3 scoops of sugar. Again, the word problem itself kind of gave us some hints as to what it wanted us to do. It gave us these two numbers. It said we needed 2/3, but we only had a 1/4 scooper. How many scoops of sugar will you need to make the cake? Well, let's see here. If 2/3 is bigger than 1/4, as we found out here, we wanted to see how many of these went into here total. And we're talking about seeing how many of them go into something, rather than just keep subtracting and subtracting until we can just get to a number like probably 0. We can divide these two. So when we're dividing 2/3 and 1/4, just like how we learned, first, we want to find the reciprocal of the second fraction. 1/4 turns into 4/1. Then we multiply 2/3 times 4/1. 2 times 4 makes 8. 3 times 1 makes 3. And that is our final quotient. I hope you guys were able to work this one out. If you didn't get that answer, that's okay. If you did, awesome. The point is here is that we're just trying our best. And it takes some time to work on these analytical skills, especially with word problems. Okay, everyone, as we wrap up this video, I want us to look at some key ideas, okay? These are things that I want to make sure that we get out of this lesson. That way we know exactly how to multiply and divide or find the product or quotient of fractions. In the case of multiplication, you must multiply the numerators and then the denominators. So, in the case of our particular example, 2/7 times 6/8, we're going to multiply 2 times 6 in the numerator, that gives us a 12, and a 7 times 8 in the denominator, that gives us 56. Now, this is a pretty good answer, but for those of you who want to simplify this, I took the liberty of making sure I could find its simplest form. I divided both of these by 4, and that gave me 3/14. When we're dividing our fractions, first we want to find the reciprocal of the second fraction, and then we're going to multiply. Okay, so in the case here of 5/8 divided by 4/5, what we do is we find the reciprocal of the second fraction. I already took the liberty of doing that. That turns 4/5 into 5/4, and then we multiply. That is 5/8 times 5/4. And just like our multiplication, 5 times 5 gives us 25 in the numerator, 8 times 4 gives us 32 in the denominator. Again, this may seem like we're multiplying these two, but by finding that reciprocal, we're kind of doing something different. We're dividing, but it's just, well, opposite. It's flipped. So that's why it's not the same as the multiplying and dividing part. Last but not least, we want to think about the same positive and negative rules apply when we're multiplying and dividing fractions as they do for integers, okay? So that means if you're multiplying and dividing a positive and a positive, that gives you a positive result. If you're multiplying a negative and a negative, well, that also gives you a positive result. If you're multiplying or dividing a positive and negative, you will get a negative result. And similarly, if you're multiplying and dividing a negative and a positive, it will give you a negative. Remember, same signs result in a positive, different signs result in a negative. I want to thank you for taking the time to watch Number Systems Lesson 4 for the week of April 20th through April 24th. Now, this lesson is the last lesson that goes over any new content, as all of the Number Systems packet, well, most of it just kind of goes over what we talked about, the adding and subtracting of integers, positive and negative numbers, the multiplying and dividing of integers, and the adding and subtracting of fractions, and the multiplying and dividing of fractions, as well as some things in between that we learned. Now, we do have one more week of number systems, so for the next couple of videos, for what I'm going to do is we're just going to go over some number systems review and practice. That means we're going to try some maybe more difficult problems. We're going to get some time to work on those ourselves as well as go over them together and, well, just kind of work those out and make sure that we're getting everything we need to get out of these videos, okay? So until next time, guys, I want to thank you again. Remember, keep practicing your math and hope to see you guys soon.